Hello everyone. In this video, we'll be discussing multi-threading programming. But before discussing multi-threading programming in Java, we will be discussing few different things as well. So we'll be discussing what's the difference between multi-programming, multi-processing, multitasking, and multi-threading. So I'm just trying to give you very simple examples so that it's easier for all of you to understand. So what is multi-programming? If you see the image over here, you can see, let's say we have a processor in our computer and we are running Microsoft Word, Excel, Chrome browser, right? So we are doing multiple things at the same time. That is called multi-programming. Then what is multi-processing? So nowadays we are using like multiple processor inside our computer, laptop, right? So when we'll be using multiple programs, and to run that programs we'll be using multiple processor to process all of this program so that we can get our result faster. That is called multi-processing. Then what is multitasking? Multitasking is another form of multi-programming. So there is a subtle difference between these two. Multi-programming works on the concept of context switching, where multitasking is based on time sharing. So what it is doing, there is some operating system algorithm. So sometimes it works on based on the context switching, sometimes it works on like context switching and time sharing. So when we'll be doing both context switching and time sharing, that is considered as multitasking. So what could be an example of multitasking? So let's say if we are using terminal, we could have a processor. Under that processor, by using that processor we can open like multiple terminal to process multiple things together. So that could be an example of multitasking. And what is multi-threading? So let's say we are using Microsoft Word, and what we are doing, we are writing something. So Microsoft Word is taking that one as an input. We are saving, or Microsoft Word is saving that information automatically, and then it is checking the grammar in parallel as well. So this is what could be a good example of multi-threading programming. So what is multi-threading programming actually? So when a task is submitted by the user, then it is subdivided into subtask or thread. When these multiple subtasks run in multitasking environment, then it is called multi-threading. So I already discussed about the example. What could be the perfect example of multi-threading? So using Microsoft Word, where we are typing, it is saving the data and it is checking the grammar in parallel as well. So we already know the benefit of using multi-threading, right? So we can do like all the things or multiple things together. It will not hamper any performance, and we can process all the things pretty easily and faster. So there should be two different ways of creating thread in Java. So how we can do that? The one approach we can take is called extending thread class, or we can implement runnable interface. So there are few common methods that is what we should know when we'll be dealing with multi-threading programming, or when we'll be dealing with like threads in Java. So what are those methods? Get name, get priority, get is alive, join, run, sleep, start, and so on. So I just want you guys to search more on all these methods and see how we can use all of this. Now let me show you guys a quick demonstration how we can use multi-threading programming in Java. So here I already created a class called summation Java. So if you see this class is actually extending thread class. There will be another way of using thread is implementing runnable. But in this example, we are actually extending the thread. There are a few different methods defined here, but let's go back to the main method. Let me explain what we are trying to do here. Here you see we actually declared an array of a huge element, and then the size of this array is pretty big, and we wanna calculate the summation whatever is inside this array, and we'll be using a single thread and a multi-threading approach to calculate the total summation of that number. And we'll see like how long would it take in a single thread and how long would it take in multi-threading programming. Okay, so here you see, if we come here in parallel summation, in this method we are displaying here how many processors I have in my machine right now, and based on that we'll be doing the parallel processing. Okay, so in this thread we are doing some calculations. If you go through the code, then you will be easily understanding what is happening here. But one interesting thing you can observe here, so here you see, let's say when we are doing all the summation, like we are using multiple different threads of like adding all these values, and then we'll be looping through all of these inside this array, and we'll be joining one by one. So what will happen, so when all the threads will be done, then we just need to join them back, right? So that is one of the method of thread, and then we'll be displaying this result. So let me run this program and let me see, let me show you what is the output we are getting here. So it is running. Here you see, so in a single thread environment, just to calculate all these, it was taking 69 milliseconds, and we are using like 4 processors here, because in this machine we have 4 processor. I mean I have 4 processor, and when we are using multi-threading environment, this is taking actually 50 milliseconds, although like it is a very little difference between 50 milliseconds and 69 milliseconds, because we are doing like very simple operations here, right? So when we'll be doing like larger operations with more complex application, then like yeah, this time like means a lot, right? So this difference is a significant difference between a single thread environment and multi-thread in like environment and multi-threading programming actually. So I hope you understand this. And let me give you like another real life example where we can use multi-threading programming. So let's say we have a scenario, so husband and wife, they have some account in a bank, and then they wanna withdraw the money from the same banking account. Both of them has access on the same account, right? So how we can tackle this thing? So here is an example. So here you see we have a class called account, and under this account the balance is 50, and there is 2 method called get balance and withdraw balance. So let's say in this account testing is actually implements runnable. So this is a threading environment or threading program, right? So we are defining 2 different thread here, thread 1 and 2. We are setting the name over here, Ranjit and Rima, husband and wife, and they just wanna withdraw the values from here, right? So this is the run method, and this is withdraw method. Okay, so what will be the output if we run this program? So here you see like Ranjit is going to withdraw, and then Rima is going to withdraw. Rima completes the withdrawal, then Rima is going to withdraw again. So like something interesting happening here. So if you see the output, so Ranjit is going to withdraw, but he is not done yet with his withdrawal. But at the like before completing his withdrawal, Rima is going to withdraw. So that's a problem. This problem is called like a rest condition. So when multiple threads can access the same resources, this problem occurs, and that is known as like rest condition. So how we can actually tackle this? So we have to use like synchronization keyword. So if we use synchronization keyword inside the way when we are declaring a method, then this thing won't happen. So when some resource is blocked or occupied by someone, then until he or she completes his operations, no one can access on the same resource, right? So what we are doing here, if you see, like previously we didn't use like this synchronize keyword with this make withdrawal method, right? So we are just adding this synchronize keyword over here, and that will resolve all these problems. So if you run the program again, I would suggest you guys to copy this code and run them in IDE, and you will see like what will be the output. So here you see Ranjit is going to withdraw, then Ranjit completes his withdrawal, and Ranjit is trying to do the same thing. So how many times we can do this? We'll be able to do this for 5 times, and then the balance will be 0, and then we are not gonna execute any amount from this bank account. So this is another interesting example of multi-threading programming as well. I hope this was helpful for all of you. Thanks so much.